Sometimes adding and subtracting radical expressions is a little bit less straightforward. Let's suppose we met a radical expression that looks like this. Square root 50 plus square root 98. At first glance, it looks like those are unlike radicals and there's nothing we're going to be able to do with them. But wait. Right now, these are square roots, so we have two methods for simplifying these. But since we're in kind of our radical frame of mind, let's just factor these guys into primes. Right, 50, that's 10 times 5, and 10 is 2 times 5. So this is going to be the square root of 2 times 5 squared. 98. Well, that's an even number. It's 2 times 49. Oh, and 49 is 7 times 7. So this is the square root of 2 times 7 squared. So I'll have the square root of 5 squared times the square root of 2 plus the square root of 7 squared times the square root of 2. Square root of 5 squared is 5. Square root of 7 squared is 7. And now, all of a sudden, these are like radicals. I can combine them. 5 plus 7, 12 root 2. Let's see another example. Let's say we want to add cube root 3 over cube root 2 plus cube root 96. These definitely don't look like radicals. But let's see what happens. This guy is complicated enough. I'm going to want to simplify these separately. I've got cube root 3 over cube root 2. I can see that if I combine these, I'm not going to be able to cancel any common factors. So I'm going to go straight ahead to rationalize the denominator. 2 is already prime, so I need to multiply it by 2 squared to get 2 cubed. So I'm going to multiply the numerator also by the cube root 2 squared. And I'll be left with, well, the cube root 2 cubed in the denominator. In the numerator, the cube root, I can see I'm not going to be able to simplify, so I'll go ahead and multiply it out. 12. So this is the cube root 12 over 2. This other expression, cube root 96, 96 I'll factor into primes. Gosh, well that's an even number. It's 2 times 48. 48 is 8 times 6. 8 is 2 times 2 times 2. And 6 is 2 times 3. So let's see. How many 2's have I got? 1, 2, 3, 4, 5. And just the 1 3. What multiple of 3 is closest to 5? 3. So I'll have the cube root 2 cubed times the cube root 2 squared times 3. So that'll be 2 times the cube root 12. Oh, those are like radicals. All right, I'll have cube root 12 over 2 plus 2 cube root 12. Or let's think of this as cube root 12 over 2 plus 2 cube root 12 over 1. Let's get a common denominator. Multiply the numerator and denominator both by 2. And this will give me 5 cube root 12 over 2. So very startlingly, these turn out to be like radicals after we simplify and rationalize the denominators. For the record, this is another advantage of rationalizing denominators. It makes it easy to recognize like radicals. So I'm going to give you one of these to try, one where you need to simplify first. Add cube root 81 plus cube root 192. Pause the video and try this now. Alright, in order to simplify these, we're going to have to factor each of these numbers into primes. So let's see, 81 is 9 times 9 is 3 times 3 times 3 times 3. So we've got the cube root 3 to the 4th, 192, that's even. So it's going to be 2 times 96. Still even, so we're going to have 2 times 48. 48 is 8 times 6. 8 is 2 times 2 times 2. And 6 is 2 times 3. So, gosh, that's a lot of 2's. 1, 2, 3, 4, 5, 6 2's. And just the 1 3. Okay. Multiple of 4 that's closest to 3 is just 3. 6 is a multiple of 3. Cube root 3 is just 3. Cube root 3 cubed is just 3. Cube root 2 to the 6th is 2 squared. So we'll have 3 cube root 3 plus 4 cube root 3. Those are like radicals. And we're left with 7 cube root 3.